The James Webb Space Telescope, or JWST, has once again pushed the boundaries of human knowledge and reshaped how we see our place in the cosmos. Since its launch, this extraordinary observatory has provided us with breathtaking glimpses into the farthest corners of the universe, revealing galaxies formed billions of years ago, unearthing mysteries surrounding black holes, and painting an intricate picture of cosmic evolution. But this time, JWST has set its gaze much closer to home, toward one of the most tantalizing destinations in our stellar neighborhood. Proxima Centauri B, often simply called Proxima B. This planet orbits the small red dwarf star Proxima Centauri, the closest star to our solar system, just over 4.2 light-years away. That distance, while vast by human standards, is incredibly close in cosmic terms. Close enough that if technology advanced far beyond today's capabilities, a robotic probe could potentially reach the system within a human lifetime. What makes Proxima B so intriguing is its location within the habitable zone of its star, a region where temperatures could, at least in theory, allow liquid water to exist on the surface. Water, as we know, is one of the key ingredients for life as we understand it, and its potential presence raises the stakes enormously. Now, with JWST's unprecedented precision, astronomers have begun to unlock details about Proxima B that go far beyond speculation. Early findings already hint not only at the possibility of habitability, but also at conditions that could indicate an active environment, or even signs of life itself. Unlike Earth, Proxima B is most likely tidally locked. This means that one side of the planet permanently faces its star, bathed in unending daylight, while the other side remains locked in perpetual night, cloaked in darkness. For a long time, scientists worried that this configuration would render the planet uninhabitable, the day side would scorch, and the night side would freeze. Yet, in recent years, models have suggested that habitability could still be possible if the planet had an atmosphere capable of redistributing heat. In that case, the most promising area for life would be a narrowed twilight belt along the terminator zone, the border where day meets night. JWST's sensitive infrared instruments have now provided atmospheric readings of Proxima B that strongly reinforce this theory. By studying the spectrum of the planet's atmosphere as it transited its star, astronomers detected temperature gradients and patterns of heat transfer consistent with an atmosphere that circulates energy. This circulation, heat moving from the day side into the dark hemisphere, is one of the fundamental traits of a climate capable of supporting stability. In other words, Proxima B may not be an uninhabitable frozen rock or scorched wasteland, but a world where conditions remain surprisingly Earth-like in at least some regions. The findings become even more compelling when we examine the trace gases detected in Proxima B's atmosphere. Among them was methane, present in quantities difficult to explain by non-biological processes alone. Methane can be generated geologically through volcanism or hydrothermal activity, but such processes usually also produce byproducts like carbon monoxide. In Proxima B's case, those markers were notably absent. On Earth, large amounts of methane without corresponding geological byproducts often point to biological sources, microorganisms that release methane as part of their life cycle. But methane wasn't the only surprise. JWST spectroscopic data also revealed an absorption feature resembling chlorofluorocarbons, CFCs. On Earth, these are entirely artificial compounds with no natural origin, created by industrial processes. Their presence in Proxima B's atmosphere, if confirmed, would be extraordinary, potential evidence of technological activity. Researchers are cautious, stressing that the data is preliminary, and alternative explanations involving unknown chemical or geological processes are possible. Still, the very hint of such a signature has ignited debates across the scientific community. If the CFC-like feature is real, it would mark the first ever detection of a non-natural compound on an alien world. The planet's albedo, a measure of reflectivity, was also found to vary across its surface or atmosphere. This variability suggests dynamic processes at play. Cloud systems, oceans, ice caps, or even vegetation could cause such differences. Although JWST cannot yet directly image Proxima B's surface, the way the light curves shifted over time hinted at rotating surface features or active weather patterns. A barren rock world rarely exhibits such complexity. Instead, these findings support the possibility of oceans, continents, or atmospheric cycles that resemble those of Earth. Another crucial factor in sustaining life is atmospheric density. Proxima B's atmosphere was found to be thicker than previously assumed. This is significant because a thin atmosphere, like Mars, fails to hold heat or protect against stellar radiation. A denser one, like Earth's, not only regulates temperature and allows water to remain liquid but also acts as a shield. JWST's data even showed scattering of stellar radiation in ways similar to Earth's sky, suggesting the presence of complex molecules or aerosols suspended in the air. The findings didn't stop there. While JWST cannot directly detect magnetic fields, it observed indirect evidence that Proxima B may possess a magnetosphere. Proxima Centauri is a highly active star, producing frequent flares that should strip away planetary atmospheres. Yet Proxima B's atmosphere remained intact and stable, far more so than models predicted. The most likely explanation is a magnetic field deflecting much of the charged particle bombardment, just as Earth's magnetosphere shields us. Without such protection, any surface life would struggle against radiation. JWST's observations across multiple months also revealed something remarkable: long-term atmospheric stability. Despite minor fluctuations, the planet's atmosphere remained consistent in composition and temperature. On Earth, this kind of planetary balance is largely maintained by feedback loops involving both biology and geology. To see similar hints on Proxima B suggests a self-regulating system, a hallmark of a world that is not just passively existing but actively balancing its environment. Even more astonishing were the thermal readings of Proxima B's night side. It was warmer than expected, suggesting that something besides atmospheric circulation may be contributing to heat. This could point to geothermal activity beneath the surface, perhaps even tectonics or volcanism. On Earth, such processes play a critical role in driving ecosystems, especially in the deep ocean, where hydrothermal vents support entire communities of organisms without sunlight. If similar systems exist on Proxima B, life there might not be confined to the surface but could thrive underground or in subsurface oceans. The implications extend beyond Proxima B itself. JWST's findings challenge old assumptions about planets orbiting M-type red dwarfs, which were long thought to be too hostile for habitability. With discoveries like these, scientists are re-examining countless exoplanets orbiting such stars. Proxima B is no longer seen as an odd outlier. It may be part of a larger pattern of worlds that are more resilient than we ever imagined. Looking ahead, other observatories will help confirm and expand upon JWST's work. The extremely large telescope, ELT, in Chile, currently under construction, will be able to observe exoplanets with unmatched resolution. The upcoming Nancy Grace Roman Space Telescope will further contribute to refining models of exoplanet atmospheres. Together, these instruments could validate JWST's tantalizing hints of methane, unusual spectral signatures, and atmospheric stability. Meanwhile, radio telescopes operated by the SETI Institute are already listening to Proxima Centauri, scanning for unusual electromagnetic signals that might indicate intelligent activity. If even a fraction of JWST's data holds up under scrutiny, Proxima B could become the single most important target in the search for extraterrestrial life. Imagine it. Just over 4 light-years away, practically in our cosmic backyard, may lie a planet not only capable of supporting life but perhaps already hosting it, whether microbial, complex, or even technological. For decades, humanity has gazed into the stars, asking the age-old question, are we alone? Thanks to the James Webb Space Telescope, we may finally be closer to an answer than ever before. What JWST has given us is not just another discovery, it is a doorway. A window into the possibility that one of the nearest worlds to our own may be alive. Whether life on Proxima B proves to be microbial, complex, or even intelligent, the significance is staggering. If confirmed, it would transform our understanding of biology, evolution, and our place in the universe. Here at Discovery 2.0, we will continue to follow every breakthrough, every analysis, and every observation that brings us closer to solving this cosmic mystery. The search for life, for understanding, and for our role in the grand tapestry of the universe is far from over. In fact, it has only just begun.